Hey, welcome to the Explainer. Today, we're going to tackle a problem that I think pretty much everyone has. You've got all this data, right? Just piles of it. But how do you actually turn those raw numbers into something useful, real insights, without wanting to pull your hair out with a calculator for hours? Well, let's dive in and find out.
No, really, just stop and think about that for a second. What if, instead of you having to do all the work, all the number crunching, your data could just answer its own questions? What if it could just tell you the total sales, or figure out a monthly loan payment, or calculate the average price, just like that?
Well, it absolutely can. And that's exactly what we're going to break down in this explainer. We're going to show you how to make your data do the math for you. You build the logic right in, so the answers you need are always just there, always up to date and always accurate.
Okay, so first up, let's talk about this whole idea of data that calculates itself.
See, raw data on its own, it's just a big list of numbers, right? It doesn't really tell you anything. The insights, well, those are the answers you get from those numbers. And that's the gap we're trying to close here. We want to go from just a boring, static list to a dynamic system that actually generates those answers for us. Because let's be honest, raw data is kind of passive, but it's the insights that help you make real decisions.
So the big question is, how do we actually do this? Well, let's meet the hero of our story today, the calculated field.
Okay, so what is a calculated field? In its simplest terms, it's a special kind of field or column in your database. But here's the trick. You don't type data into it. Instead, you put a formula in it. So it's always watching other fields, maybe like a price field and a quantity field, and then it automatically does the math to give you the total cost. And when you compare this to the old way of doing things, wow, the difference is night and day. I mean, trying to calculate everything by hand, that's just asking for trouble, right? Typos, old numbers you forgot to update, it's a mess. But a calculated field, it just solves all of that. It's always accurate, it updates instantly, and it's totally dynamic. You change the quantity from 2 to 3 and bam, the total is updated right away. No extra work for you. So, you might be thinking this sounds complicated to build, but honestly, it's simpler than it looks. It's kind of like a recipe with just a few basic ingredients. You've got your standard math stuff, plus, minus, times, divide. You've got constants, which are just values that don't change, like a tax rate. You use your field names, we call those identifiers. And then you have these awesome shortcuts called functions. And yep, remember high school math? The order you do things in really, really matters. Databases follow that same classic order of operations. You might remember it as PEMDAS. Parentheses first, then exponents, multiplication, and so on. Getting this right is honestly the secret to avoiding a ton of really common and, frankly, super confusing mistakes.
All right, section 3. Now, basic math is cool and all, but we can seriously supercharge our calculations by using built-in functions.
So, what's a function? The best way to think about it is like a pre-made recipe from some master chef. Instead of you trying to figure out all the super complex steps to calculate, say, a loan payment, you just grab the payment function, give it the few ingredients it asks for, and it does all the heavy lifting for you. It's a huge time saver. And the amount of power we're talking about here is just incredible. A tool like Microsoft Access has more than 150 of these things built right in. That's like having a giant library of pre-made formulas ready to go for pretty much anything you can think of, from complex financial stuff to just working with text. Let's take a look at a classic one, the payment function, or PMT for short. So imagine you've got a loan amount, an interest rate, and the number of years to pay it off. Instead of you having to wrestle with some crazy-looking financial formula, you just call this one function, and poof, it gives you the exact monthly payment, instantly. Now, I know when you first see it written out, the syntax can look a little scary, but the idea behind it is super simple. A function just needs a few pieces of information from you. We call these arguments. So for that PMT function, you just need to tell it the interest rate, how many payments you're making, and the total loan amount. You plug those 3 things in, and it spits out the answer. That's it.
Okay, section 4. So far, everything we've talked about has been happening on a single row at a time. But now, let's zoom out and see how we can summarize entire sets of data.
The way we do this is with something called an aggregate function. I know, the name sounds super technical, but trust me, the idea is really easy. It's basically a function that zooms out, looks at an entire column of your data, like say all your sales for the whole month, and it boils it all down to a single summary value. It could be the total sum, the average, or even just a count of how many sales there were.
And there are basically two main ways you can use these aggregate functions. The first is what's called a total row, and it's perfect for those big, simple questions like, what's the grand total of all my sales? But the second way, a totals query, is way, way more powerful. That's what lets you ask much more interesting questions like, okay, what are my total sales, but broken down by city? To really get a feel for the difference, let's just walk through a quick example. So imagine you've got a simple list of all the houses you sold this year. You've got the sale price, and you've got the city each house is in. Okay, so if you use that simple total row to find the average price, you get one single number, $350,000. And hey, that's kind of useful, right? But it's a very broad, high-level number. It's the average across all the cities combined.
But what happens when someone asks a smarter question, like, what's the average price in City A compared to City B? All of a sudden, your simple total row is useless. It can't answer that. To do that, you need to group your data. And this is where the totals query becomes your best friend. Because you can group the calculation by the city field, you get this much richer, more detailed answer. Now you can see, clear as day, that homes in City A are selling for way more on average than in City B. And that is a real, actionable insight that was totally hidden when we just had that one big number. All right, last section. Let's talk about mastering your queries. Look, creating these calculations is awesome, but you have to be sure they're right. That's everything. So let's go over a few super common pitfalls you'll want to avoid. First one, it's a tiny little syntax error, but it'll stop you dead in your tracks. When you give your calculated field a name, like monthly payment, you absolutely have to put a colon right after it. If you forget that colon, the database just gets confused and has no idea what you want it to do. It's such a small thing, but it will completely break your calculation. Okay, here's another one that gets absolutely everyone at some point. A simple spelling error. If you misspell a field name in your formula, like you type BAALNC with 2 A's instead of balance, the database doesn't know what you're talking about. So it'll pop up this little box asking you to enter parameter value for this mysterious field. If you ever see that box, 99% of the time, it's a typo. And finally, we're back to our old friend PEMDAS, the order of operations. Forgetting about this is so dangerous because it can give you an answer that looks perfectly fine, but is actually completely wrong. You know, adding 100 to a balance and then dividing the whole thing by 12 gives you a totally different answer than dividing 100 by 12 and then adding it to the balance. The key takeaway here is simple. When in doubt, use parentheses to force the calculation to happen in the order you want. So with all that, how can you feel confident that your numbers are actually right? Well, here's a simple 3-step check you can always do. First, just eyeball it. Do the results in your datasheet look reasonable? Do they pass the common sense test? Second, grab a calculator and just manually double-check a couple of the records yourself. And third, if it's a really complex calculation, hey, there's no shame in copying the data over to something like Excel and just confirming the math there. Always trust but verify. Look, at the end of the day, making your data do the math for you is all about unlocking the stories that are hidden inside it. It's about finally moving past just collecting information and starting to ask those really smart, insightful questions. So really, the only thing left to think about is, what questions are you going to ask?